guys, welcome to another tutorial of SmartBukites on the course Engineering Mathematics. Today we will be solving a question on eigenvalues and eigenvectors. We are given a question which says that consider the equation a dot x is equal to lambda x where A is a matrix and is given by 4, 1, 3, 2. Obtain the eigenvalues at the A part, and at the B parts we are asked to find the corresponding eigenvectors. So, solving this solution, we're going to be finding the eigenvectors. So, finding the eigenvectors, we are going to multiply our matrix, which is A, by an identity matrix. We are going to be subtracting lambda, and lambda will be multiplied by an identity matrix, which is 1, 0, 0, 1. So therefore this is equal to 4, 3, 1, 2, open bracket. So if you should open the bracket, open the matrix with lambda, lambda times 1 is lambda, here is 0, here is 0, and here is lambda. So now subtracting these two matrices together, we'll be left with 4 minus lambda, 1, because 1 minus 0 is 0. The other one, 3 minus 0 is 3. Then we have 2 minus lambda. So now multiplying this matrix, now we are going to multiply this element of the matrix by this element and subtract it from the multiplication of this element of the matrix multiplied by this element of the matrix. So now we are having 4 minus lambda multiplied by 2 minus lambda. This is lambda minus times 1, because we multiplied 3 times 1, minus 4 lambda multiplied by minus 2 lambda. So therefore 4 times 2, which is 8, 4 times minus lambda, we have minus 4 lambda, minus lambda times 2, we have minus 2 lambda, minus lambda times minus lambda, we have plus lambda squared, minus 3 times 1, which is 3. Now we'll be left with, this is equal to, starting from the higher order, we are having lambda squared minus 4 lambda minus 2 lambda, which is minus 6 lambda, minus 6 lambda, 8 minus 3, which is 5, 8 minus 3, which is plus 5. So here, this is a quadratic equation. So we'll look for 1 times 5, which is 5, then minus 3. So we are going to look for two values, of which if we multiply them, it will give us 5, and if we add them, it's going to give us minus 6. So these two values are minus 1 and minus 5. Minus 1 and minus 5. So if we multiply minus 1 times minus 5, we are going to be left with 5. If we add minus 1, minus 5, we will be left with 6. So therefore, we'll be left with lambda squared minus, instead of putting minus 6 lambda, we will put in minus lambda minus 5 lambda plus 5. So factoring lambda out here, we will be left with what? We will be left with lambda minus 1. Here also factoring minus 5 out, we will be left with lambda 5, lambda minus 1, because minus 5 divided by 5 is minus 1. So now here we will be left with lambda minus 5, lambda minus 1. So therefore, equating each of these equations to 0, we will be left with minus 5 is equal to 0, and lambda minus 1 is equal to 0. Our lambda is 5 and our lambda is 1. So this is our eigenvalues. Values for this question. Eigenvalues for this question is 5 and 1. So now moving to the B part of the question, we are asked to find the eigenvectors. So now to find the eigenvectors of this question, we are going to minus lambda from our equation and multiply x to it. So B part, eigenvectors. The first one we look for was our eigenvalues. So now looking for the eigenvectors. So now we are going to be taking when lambda is, we know that our lambda is 5 and our lambda is 1. So for the first part, when lambda is 5, so at the beginning of the question in the A part, we subtracted an identity matrix of lambda from our matrix form A, which is 4, 1, 3 and 2. We subtracted it, lambda. Here we are having lambda 0 and 0 lambda. So now we are going to be treating this for when lambda is equal to 5. So for lambda equal to 5, now we are having 4, 3, 1, 2 minus 5, 0, 0, 5. So 5, when lambda is equal to 5, we are having 4 minus 5, 1. And the other part here we are having 3. Here we are having 2 minus 5. This is our matrix. And this is equal to 4 minus 5 is minus 1. Here is 1, 3. 2 minus 5 is minus 3. So we are going to multiply this by what? By x1 and x2. And the entire of this is equal to 0. So now, multiplying the matrix together now, we are going to be left with minus x1 plus x2 is equal to 0. The other one we are going to have 3x1 minus 3x2 is equal to 0. You know, if you are multiplying two matrices together, you multiply our row multiplied by the column. So this multiplied by this multiplied by this multiplied by this multiplied by this. So that was what we did here. So looking at this question very well, looking at this equation very well, we are having x2 is equal to x1 for the first equation, and for the other equation we are having 3x1 is equal to x2. So therefore we can say when our x1 is equal to 1, our x2 is also equal to 1. So this is one of our eigenvectors. This is one of our eigenvectors. Here we are having 1, 1 for x2 and x1. So when lambda is equal to 1, we are going to find the eigenvectors when lambda is equal to 1. So calculating for when lambda is equal to 1, we will bring back our matrix, which we have 4, 3, 1 and 2. Open brackets, we are subtracting. So subtracting 1 when lambda is equal to 1 from our A. Here 4 minus 1 is 3. Here is 1. Here is 3. 2 minus 1 is 1. Therefore we are having x1, x2, and they are all equal to 0. So multiplying the two matrices together, we'll be having 3x1 plus x2 is equal to 0. The other one will be having 3x1 also plus x2 is equal to 0. So here, using our equation 1, here we are having 3x1 is equal to minus x2, right? Then making x1 subject of formula, will be having minus x2 all over 3. So assume here whenever x2 is equal to 1, our x1 will be equal to 1 over 1 times 1 over 3, which is equal to minus 1 over 3. So the eigenvectors when lambda is equal to 1 are, we have x1 to be minus 1 over 3 and x2 to be 1. So therefore, finally we'll find our eigenvectors, the B eigenvectors. Our eigenvectors are, for the first one we have 1 and 1, and for the second one we are having our eigenvectors to be minus 1 over 3 and 1. So I hope you enjoyed this tutorial. Feel free to send your question, any question you are finding difficult, in the comment section. We are going to try to solve it and get back to you. Thank you for watching this video. We'll meet in our next tutorial.